Hey folks, we're gonna look at the the Jackie lead Jackie LED. I don't know. Uh, so supposedly it's got surge protection, overload protection, short circuit protection, and it's supposedly fireproof. I got this off of Amazon, and it was supposed to be pretty highly rated. So this is actually the second unit I have. The first unit, even though the box wasn't damaged, out of the box the top was all cracked, and I had to get rid of it. But I at least sent it back to Amazon. So which kind of skeptical of how well this this outlet is, given how it sounds like it's pretty fragile from the first iteration. Just even looking at it, it actually looks like it's you could see there it's a little banged up already on the plastic. Like you could see this on the plastic as if it got banged on the top side. I think the packaging isn't really great. It's probably where it's failing. All right. So it's a pretty light plastic feel. It does have like a built-in cord reel that you could wind up by winding the top against its base. The cord seems okay. It doesn't feel like it's a heavy-duty cord. It feels fairly thin. It is slightly flexible. Not the most flexible thing. So let's take a look. Get rid of this tag, see what it says. Just talks about doing the first initial unreeling of this bottom portion. It seems like every of these stack has its own switch. Even the switches, they're not you could see the switches, they are not aligned. They're all slightly turned in a different direction, and I guess they actually freely rotate, so I guess that's okay. Pretty okay detent. It still does feel pretty pretty light, like cheap plastic, unfortunately. Let's take a look with a see what this plastic's made out of. It doesn't seem, yeah, it's not, it doesn't have any fiberglass in it. It's regular molding. I think these things are actually clasping the two halves together. So let's take a look. We could pop these things off. Yeah, so they look like they just snap on. So let's take out this other side. Make sure we're in focus. Okay. Okay, and let's see if these things split like a clamshell. They may actually be held up with this top side. So there's looks like 4 Phillips screws. Let's get rid of those. Whoa. Yeah. Seems like there's a lot of play. I think the tab might already Yeah, it seems like it's pretty cheaply made. It seems like it's actually broken, on at least on for that one. Yeah, this one doesn't flex, so the top one, yeah, this one looks like it's actually broken. These are, seems like they're self-tapping screws. Okay, yeah, see, this is already broken right out of the box. Nice. Yeah, you could probably see the molding. Let's see, try to get it into focus. Let's try to get that into focus. There you go. Looks like the molding for these plastic parts are pretty, I don't know, not clean, I'd say. Not the, certainly not the not the highest quality. Let's see if this happens up. Let's get something together. See how we take this apart. I think I might need to remove these glass things. Alright, let's see if this happens up. And it seems like it should open up. Okay, so we have slide these off. See if we get it to focus. There you go. Looks like these wires in here are very rigid. The gauge on it seems a little small, especially coming in here. Not sure. I'll check what gauge these things are. And also, look at this. It seems that there's already like damage in the wire. I don't know if we could see that. I mean, it doesn't look like it completely is cut through into the to the copper, but it doesn't. This is definitely not a good indicator of quality control, especially if it is, you know, cut right into the copper. It might lead to shortages. Okay, so it looks like we have some, so if you could see this, so this thing right here, I think it is power to, I see, to power these LEDs indicator on the front side when the switch is turned on and off. And also, I think it also down converts the power to power these USB plugs. I think the switch construction on this side, it looks like okay switches, although I can't actually see the brand on it, but they look, at least the molding doesn't look like it's very chintzy. Yeah, it does look like these wires are slightly damaged. I think it's when same thing, it's a little dinged. Makes me wonder if it's a part of the assembly. The rest of it looks okay. No other indicator that it's terribly bad. I've definitely seen worse. Okay. And then there was also some protection circuit, it seems, for these things. Yeah, at least these plugs are definitely some Chinese brand. Let's see, it says MSI or something, MSL. Definitely, I've not heard of them before. So overall, I think it looks fairly clean. I think the only thing is these plastic bits are seems like it's fairly chintzy plastic. Let's test these plastic out to see if there's no, it's not glass fiber reinforced, just plain non-reinforced plastic. No indication of what type of plastic. Alright, and then I think the base is probably, it looks pretty straightforward. This thing is just fastened down, and it probably just coils in there so that when you rotate this, it will retract this cable here. It is on the base, it actually, I think that might actually be a breaker reset, and this, it actually indicates it's 16 gauge. I do wonder if it's 16 gauge or not. It does seem pretty small. Let's just see what it actually measures, if it's actually 16 gauge or not. Looks like it measures 0.0. Oh, there you can see it. There you go, 0.04 inches. So take a look, which is 16 gauge is supposed to be 1/16, which is supposed to be 0.0625 inches. So it, I think they're lying about that. Let's measure that again. Yeah, I'm getting 0.04, at least for the diameter of the copper. So it doesn't seem like it's actually 16 gauges wiring. It makes me also question these certifications. And even though it's indicated, you could see it says it says FCC, which is quite strange since it doesn't quite have any transmission. There's no, CE or UL, which is something you'd usually look for electronic safety. So this, may not actually be something that is approved to run safely on the stateside. Okay, I think that's all we have. I guess we could open up and see the breaker and actually see what amperage. Okay, so looks like it's just a coil of wire, and it it's centered around this breaker. You could see there's the breaker, and let's see if we could remove that breaker. Okay, so looks like it's just pushed in there. This looks like, we'll take a look at the part. Looks like the part number is ST, might be able to see it there, ST101E. Looks like on the unit it's actually stamped as 13 amps, so it might actually be alright. Yeah, it doesn't actually, there's some strange logo on there, but I don't actually recognize the brand based on that logo. I don't know if you could see it right there. See, it looks like some strange tree-like thing. Double check if this is also. Yeah, so that's about 0.04 as well. So I think what they're doing is, I suspect the cable that's coming into it is 16 gauge. However, yeah, on this cable here, it actually says 16 gauge. However, the lead-in from this breaker into the inside is it's not. It's closer to, you know, like a little bit over 19, almost 20 gauge. So what that means is, if you're drawing, and it's not the case that they're all hooked in parallel, right? Some of it is in, you know, parallel, but then overall, in aggregate, you know, if you plug all of these in, you're gonna have all the current running through, you know, this cable right here from this breaker switch. And so basically this, like the maximum load is basically what this wire could handle. So I'd be a little bit kind of sketched out about, you know, it saying that it's 16 when it's really not.